In this video, we're going to look at what the union and intersection are in the context of probability. These definitions will carry through the entire area of study, so it's important to recognise the differences, even if their symbols are quite similar. For those who don't know me, my name is Chris Sinozoni. I've been tutoring for about 2 years now, and I make these videos so that VCE students can do the best they can in math methods. With that out of the way, let's get into it. The best way to describe these events is with a Venn diagram. A Venn diagram is simply a visual representation of how two events are related to each other. For example, consider the case where I'm tracking the outcomes of a dice roll. The first event that I want to track is the possibility of rolling a number that is greater than 3. And the second event that I want to compare that to are all the even numbers on that dice. If we list out the sample spaces of those two events, we see that there's a bit of an overlap. The numbers 4 and 6 are both even and greater than 3 at the same time. So here's how the Venn diagram works. You start by drawing two circles that overlap each other in the center. These two circles are going to represent the events that we're keeping track of. In that overlap, you're going to put all the elements that belong to both sets. So in this case, the numbers 4 and 6. This area of the Venn diagram is called the intersection. The intersection symbol itself is highlighted in the top right. You can think of it kind of like just a wide N. So to summarize, the intersection is just the common elements between any two given events. As for the rest of the diagram, the other elements belong there as well. For example, if we wanted to fill out the left-hand side, then all we're going to do is put all the remaining elements that are greater than 3. The only one left here is going to be 5. As for the right-hand side, it's a similar story. We're just going to put all the remaining even numbers on that side. At this stage, we can now observe the union of the two events, which is simply just all the elements that belong in the Venn diagram. The notation for this one is again highlighted in the top right. You can think of this as like a wide U. But we're not quite done yet with the Venn diagram. Sometimes you'll have outliers, or elements that don't belong to either of the events that you're tracking. These outliers are going to be placed in the bottom right-hand corner of your Venn diagram. They won't exist in the circles, they are just immediately outside of it. In this case, it's going to be the numbers 1 and 3, since neither of those numbers on the dice are even or greater than 3. There are a few things worth mentioning before we get into the examples. And the first thing I want to mention is that there is actually an equation for calculating the union. You can find the union of any two events as long as you add the probability of the first event to the probability of the second event. And then at the end, you're going to subtract the intersection of both of those events. The reason why we're subtracting the intersection is to account for a double up. If we visually observe what the probabilities of A and B look like, we'll see that both of them contain the intersection. So if we were to add those probabilities together without doing anything, you would get 2 copies of that intersection. So when we subtract the intersection, all we're doing is getting rid of 1 copy of it. And finally, we'll cap this one off with a quick note on notation. The order that you write the events in for intersection and union doesn't matter. You can say A first and then B, or you can say B first and then A. These two statements are equivalent. This bit actually becomes more important later on when you start looking at conditional probabilities. This is because conditional probability works with intersections, and sometimes you'll look at that intersection and be a bit confused because the terms are the wrong way around. I just want you to remember that you can always flip those terms around. So, let's look at some examples, starting with a question about the union. In this case, we're looking for the probability that we draw either an ace or a heart. We know this is a question about union because of the keyword or. If we're trying to find the probability that one thing occurs or another thing occurs, then that's a union. So to calculate union, we're going to use the union equation. So we'll start off by calculating the probability of getting an ace. Well, there are 4 aces in a standard deck of 52 cards, so the probability of getting an ace is going to be 4 out of 52. For now, we'll leave things unsimplified. Next up, we'll do the probability of getting a heart. In this case, there are 13 hearts in a standard deck of 52 cards, so the probability of getting a heart is going to be 13 out of 52. If you don't immediately know that there are 13 hearts in a deck, then the alternative is to say that, well, hearts is just one of the 4 suits in a deck. So the probability of getting a heart is going to be 1 out of 4. From there, all you would have to do is multiply your fraction up to have that same denominator of 52. But anyway, now that we have both of those probabilities, let's find the intersection. The intersection just means we're looking for all the cards that are both aces and hearts, of which there is only 1 ace of hearts. So the probability of getting the ace of hearts is going to be 1 out of 52. All we do now is perform the arithmetic. We're going to add the two probabilities together, subtract the intersection, and after you simplify, you're going to get a final probability of 4 out of 13. In this example, we're given information about how people spent their weekend, whether they went to the beach or to the movies. The question is specifically asking us how many people went to the movies but not the beach. Mathematically, this would be represented by an intersection, and this kind of question in particular would be best solved using a Venn diagram. I'm going to use M for movies and B for beach. It's typically easiest to start with the intersection and then work your way out. In this case, we're told that of the 22 people who went to the beach, 12 also went to the movies. So we have beach and movies, hence that's going to be an intersection. From there, we can assume that if 12 of the 22 did go to the movies, then it must mean that the remaining 10 people did not go to the movies. So we're going to put that on the right-hand side as people who went to the beach but not the movies. All that's left to do here is find the left-hand side, which is that intersection that we want. Well, if 35 people in total went to either the beach or the movies, then all we're going to do is subtract the 22 people that we know definitely went to the beach, and the remaining is just going to be those who went to the movies. If you want to complete this Venn diagram with the outliers, then you can subtract the 35 people who did do an activity on the weekend and subtract that from the 50 total people that were surveyed. From here, we conclude that 13 people went to the movies but not the beach. If you were instead asked to write this as a probability, all you would do is divide by your total group size of 50. If you found this video helpful, then you should consider joining my free community. I host a Q&A call every week to personally help you through any of your specific questions, and you'll also get access to more resources like this, including written and recorded lecture content, as well as practice exams and SACs with detailed solutions. It's pretty cool, you should check it out. I'll see you there.